Hi everyone, my name is Ravi Prakash and this is his 11th class of geometry. Okay, so we are continuing this concept from 10th class of geometry only, right? That is previous class. Now the question here is how many distinct triangles can be formed with integral sides if perimeter of triangle is equal to 39? Okay, and with all sides odd and with two sides even and one side odd, right? So similar question we did in the at the last of the previous video where we discussed about the uh, same question where perimeter was even number. Here the perimeter is odd number, right? So how to tackle this kind of question we'll see. Now see, with perimeter with all three sides as odd, right? So let's say again make a triangle ABC, sides are ABC, right? So it's given that A plus B plus C is equal to 39. Now I have to make all sides odd, right? How to make all sides odd? So I'll replace A with 2A minus 1. I'll replace B with 2B minus 1 and I'll replace C with 2C minus 1. We get capital A, capital B, capital C. This is equal to 39. Right. Now, why I've taken 2A minus 1? Because I want to start from 1, right? No, not 2A plus 1 because I want to start from 1. I want to keep A equal to 0. So I want to keep A equal to 1. So at A equal to 1, at capital A equal to 1, small a will be equal to 1, right? And whatever value you put for this capital A, now small a will always be odd, starting from 1, right? So that's how you make any number as odd, right? So 2a minus 1 plus 2b minus 1 plus 2c minus 1 equals 39. Okay, now, so 2a, okay, plus 2b plus 2c is equal to 42. Therefore, a plus b plus c is equal to how much? 21. Okay, so a plus b plus is 21 now. Now, normal solution it comes to, right? This 21, it's an odd number. So, total number of triangles for odd number, how much? So, total number of triangles for odd number is how much? P plus 3 square by 48, right? Remember? P plus 3 whole square by 48, where 48 is the inside the nearest integer function. It becomes 24 square by 48, right? So, it basically becomes 24 square by 48. Fine. That is again same thing here. 24 square is 576 by 48, it will be 12. So 12 is the answer for this question, right? So how many triangles with all sides odd? There will be 12 triangles I can form with all sides being odd, right? Okay, fine. Now this is the answer for first part, right? This is the answer for first part. Okay. Now second part, again connect to previous video, last question, right? Second part I'll discuss now. Let me rub this part. So second part was basically, if you remember, it consisted of only two cases, right? In last case it was even number. Even number, it consisted of only two cases because in first case all was even. Second case 2 was odd and 1 was even, would result in even number, right? This I'm talking about last video, last question. In this question, now you see, again, should write solution for 2. Again, now a plus b plus c is equal to 39. Great, right? But a plus b plus c equal to 39 now, and here this, understand this concept here, right? I'll get odd result. This 39 is odd. When I'll get odd only when a is odd as well as b is odd as well as c is odd, right? So odd plus odd plus odd will give me odd. This is the first case. This is the case 1, right? And another case I'll get all result as odd as any 2 as odd. So sorry, any 1 as odd and 2 as even, right? That is even plus odd will also give me odd, right? Is there any other case with a plus b plus c equal to 39? That is an odd number. So with is there any other case apart from these two where a plus b plus c is an odd number? Only two cases, right? There is no other case apart from these two. First case, odd. Second case, even, odd, right? Okay. Now, what is the answer for first case? We remember last question, right? Answer was 12. We just solved it. Answer was 12 for this question, right? Now, how many total number of triangles? What is the answer for this case now here, right? So answer for this total triangles. How many total triangles? Total triangles here is, now what is total triangle? How much? 39 is an odd number, right? So p plus 3 whole square is 48. So 42 square by 48. This is the total number of triangle, right? What is 42 square? 1764 by 48 in nearest integer function. Okay, now how much it is? So you can just solve it. 48 into 3 is 172. 32 and 4, 324. So 48 into 6 is 288. It's around, it is 36.7 around, roughly, right? That means it is more than 36.5, right? So if it is more than 36.5, there has to be 37 triangles. There has to be 37 triangles, right? Very important. So if there are 37 triangles here, so total triangles is 37. Out of this case 1 triangles, case 1 triangle is how much? 12, right? So obviously 37 will be what? Sum of 12 plus this one. So what we are left with? 25. So 37 minus 12, what is the answer? 25. So 25 is the answer for this question, right? For question 2, what is the answer? Answer for question 2 is how much? 25. Right. So very good question. Again, same thing, right? A plus B plus C is an odd number. It will be odd in only 2 cases. When all 3 are odd, or when any 2 are even and 1 is odd, right? So even plus even is even plus even is even, and odd, even plus odd is odd. So total result is odd, right? So this total number of triangles consists of only 2 cases, right? Either case 1 or case 2. Sorry, not either case 1, case 1 and case 2. So we already solved for case 1, the previous question, right? How much it was? It was 12. Answer was 12, right? So out of 37 triangles, out of total 37 triangles, 12 is in case 1. So how much is left for case 2? 25. So 25 is the answer. So 25 is the answer, right? Very good question. Very good question. Please put a star mark and revise this question, right? Okay, now next one. So this kind of concepts we have covered now, right? Every concept of this kind can be covered. I've covered all the concept: condition for triangle formation, acute, obtuse, right angle triangle, scalene, isosceles, equilateral, total number of triangles when perimeter is given also, right? So every case is covered. Not a single question can be asked in this concept in your any examination, my guarantee, right? Now different question here. Take a different variety here. Question: if perimeter of a triangle is equal to 60, then which of the following cannot be the area of the triangle, right? So put some options here: 151, B 159, C 169, and D 176. Okay, so if perimeter of a triangle is 60, then which of the following cannot be the area of triangle, right? And we can write one important concept here. If perimeter is constant, if perimeter is some constant, then area is maximum in case of equilateral triangle. In case of equilateral triangle, right? So we'll get the maximum area in case of equilateral triangle, right? So what is triangle? So triangle is like 20, 20 and 20. Then the perimeter will be 60. It's an equilateral triangle. What is the area of equilateral triangle? So area of equilateral triangle, remember for now, we'll discuss equilateral triangle in detail, right? Area for equilateral triangle is how much? Root 3 by 4 into a square into side square, right? But we'll just remember for now, we'll discuss equilateral triangle in detail, right, in the coming videos, right? So root 3 by 4 into side square. So root 3 by 4 into 20 square, right? That is 100 root 3. Now root 3 is around 1.73. So 100 into 1.73. So you see it's around 173. So 173 can be the maximum area. Right? So which of the following cannot be the area of the triangle? Which of the following cannot be the area of the triangle? So obviously, if 173 is maximum, so A, B, C can be the area of triangle. D cannot be the area of triangle, right? So answer for this question is D. Okay, because perimeter is constant, so area will be maximum only in case of equilateral triangle, right? That means when that perimeter is equally divided into three sides. So if perimeter is 60, 20, 20 and 20, right? So what is the maximum area I'm getting? If perimeter is 60, the maximum area I can get is 173, right? But option contains what? 176. And question was which of the following cannot be the area of triangle? So what is the answer? 176. Okay. So again a good concept, right? Note it down. Now, next one we'll do. Next question. Next concept we'll do. Basically, I should write next concept. See, in triangles, there are two important concepts like sine rule and cosine rule. Sine rule and cosine rule. Right. Now, let me make a triangle here. I'll make a triangle ABC. Triangle ABC. By convention, how we write? Capital A opposite to small a, capital B opposite to small b, capital C opposite to small c, right? So sides are A, B and C, right? Now this is angle A, angle B, angle C. So what does sine rule say? Sine rule says that A upon sine A is equal to B upon sine B is equal to C upon sine C, right? If you don't remember the values of sine and cos, right, these are basic trigonometry. You should remember it. So please watch my video, Basics of Trigonometry. I've discussed about trigonometry basics there, right? So A by sine A, B by sine B, C by sine C. This is the cosine rule, right? That means side and the sine of the opposite angle. So A upon sine A, right? Again, side and the sine of the opposite angle, B upon sine B. Side, that is C upon sine of the opposite angle, that is angle C, right? This is sine rule. Okay. Now cosine rule. Now cosine rule is very important. Cosine rule is very important, right? See how to write cosine rule here. So if I write cosine rule, so what is cos A here? Cos of angle A. So cos A is C. How do you remember it actually? You have to write sum of squares of all three sides, but opposite will go in negative. That means B square plus C square, opposite will go in negative. Whichever angle you are choosing, right? You'll take in cos A here. So it's like B square plus C square and opposite in negative, that is minus A square. Minus A square upon twice of product of two sides, but don't take the opposite side. That is twice of BC. So twice of BC, right? This is cosine rule, right? So how to remember? Simply sum of squares of all three sides, but opposite one will go in negative. So B square plus C square minus A square upon twice of product of two sides and don't take the opposite one. Okay, this is cosine rule for cos angle A, right? I can also write for cos B here. Let's write for cos B. Cos B. What is a cos B? So cos B opposite is a small b here, right? That means I can write A square plus C square minus B square, right? Sum of squares of all three sides, but opposite goes in negative. So A square plus C square minus B square upon twice of product of two sides, don't take opposite one. What is the opposite one here? B. So it is twice of AC. Correct? Okay. We can also write for cos C also. We can also write for cos C here. Right. So cos C here will be how much? You can write by yourself now. What is cos C? Again, sum of squares of all three sides. What is cos C? Cos of angle C. The sum of squares of all three sides, opposite one goes in negative. So A square plus B square minus C square upon twice of AC. Sorry, twice of AB. Don't take the opposite one, twice of AB, right? This cosine rule is super important. You can apply it many situations in geometry, right? And there, because it involves one angle, what does cosine rule do? It involves one angle and three sides. So total four things it involves. One angles and three sides, right? So when three sides are known, you can calculate the angle by cosine rule. Or when one angle and two sides are known, you can calculate the third side by cosine rule, right? So out of four things, whenever three things are unknown, three are known. So one unknown can be easily found. One unknown can be easily find, right? This is cosine rule, right? Very important cosine rule. Okay, now let's do a question here. Put up a question. The triangle PQR. Okay, PM is the angle bisector. That means this angle and this angle will be equal. So PM is the angle bisector. Okay, angle Q plus angle R is equal to 120 degree given. PQ is 9, PR is 12. Okay, PQ is 9, PR is 12. So question 1, what is the length of QR? Question 2, what is the length of PM? So 2 questions here, right? So a simple application of cosine rule, I'll solve it so that you get the concept here. Okay, see, first we can find the length of QR, right? QR you can easily find because angle Q plus angle R is equal to 120 degree. That means sum of 3 angles in a triangle is 180 degree. That means angle P is equal to 60 degree. So when angle P is 60 degree and PM is the angle bisector given, PM is the angle bisector. That means this is 30, this is 30. Correct. And this whole is 60. This whole is 60. Right. That means again 2 sides and 1 angle are known. I told you in cosine rule there are 4 unknown, four things here. Out of these 3 things are known. 2 sides and 1 angle is known. So I can easily calculate the third side, that is QR. Right. So I can apply for cosine rule, I can apply for cos 60. So cos 60 degree, that is cos of angle P I am applying. What is cos 60? Now again, sum of squares of all 3 sides, but opposite will go in negative. That is 9 square plus 12 square minus QR square upon twice of product of 2 sides, don't take the opposite one. That is twice of 9 into 12. Opposite is QR, don't take the opposite one, right? What is cos 60? Cos 60 is half. I'm solving first question here. Cos 60 is half. So if cos 60 is half, so this is how much? 81 plus 144, 225 minus QR square by, this is 216. Okay, so this will be 108. So this will be like QR square is equal to root 1, sorry, not root, QR square is equal to 117. That is 13 into 9, right? Therefore QR is equal to 3 root 13. This is the answer, right? So QR I got the first question. What is the answer? 3 root 13 for first question. I got the answer. Right? Now second question, finding the value of PM here, right? So finding the value of PM. Now see, there will be many things striking in your mind how to find the value of PM, right? Let's apply that triangle area formula because all 3 sides are known and I can get the value of PM, right? Or we can apply angle bisector theorem also. What is angle bisector theorem? So when PM is the perpendicular bisector, sorry, angle bisector, then the foot of the angle bisector bisects the side in the same ratio as the other 2 sides of the triangle. That means what is the ratio here? 9:12. That is 3:4. So this also will be 3:4, right? And you can divide total. What is the total length here? 3 root 13. So you can divide 3 root 13 in the ratio of 3:4, right? But you see it's very complex, right? Very complex, na? Because it's already in its roots. And when all 3 sides are known and you apply that formula, right, it's further tough because what is the formula for area of triangle? Root under S into S minus A. So already there is one root, another root will come, right? So solving is very complex, right? So that's why that 5th way of calculating area of triangle, never forget that. That's a very good formula, right? 5th way of calculating area of triangle is what? Area is equal to half AB sine theta. And I've discussed this concept earlier also, that if total area is given, they can distribute the figure. Total area is equal to sum of parts. We have done some 2 questions on this concept, right? Total area divided into sum of parts, right? That means area of triangle. That basically means what? That basically means area of triangle PQR. Okay, area of triangle PQR is equal to area of triangle PQM plus area of triangle PMR. Area of triangle PMR, right? What is area of triangle PQR? So area of triangle PQR is how much? Half AB sine theta. So half into 9 into 12 sine 60. Angle is 60, right? So half into 9 into 12 sine 60 degree is equal to area of triangle PQM. What is area of triangle PQM? So PQM area is how much? Half into 9 into PM sine 30. Angle between them is sine 30 degree, right? So two sides because I have to calculate PM also. So half into 9 into PM sine 30 degree plus area of triangle PMR, right? That is half into PM into 12 sine 30 degree, right? So you can solve this, you'll get the answer. You can solve this, you'll get the answer for PM. Answer for PM will be what? 36 root 3 by 7. You can solve it and check. So answer for PM is 36 root 3 by 7, right? So a good application of cosine rule here. A good application of cosine rule here. Okay. Okay, thank you. We'll continue in next video.